Assalamu alaikum viewers, and once again welcome to my channel. And today we are going to learn another type of integration, which is called integration by parts. Now it is noticed that learners raise the question that when they should use integration by substitution, that commonly you just call it as U substitution, and when to use integration by parts. So in that case, I must say that you have to analyze the nature of the integrand once you are intending to perform integration. If integrand is expressed as the product of two functions, out of which one function is the derivative of the other, then in that case you can easily perform the integration by substitution. And if you're having an integrand which is the product of two functions such that those two functions are totally different from each other, the one function cannot be expressed or cannot be evaluated as the derivative of the other function, then in that case you just solve that integrand by means of integration by parts. Okay, so let me give you a very normal example related to integration by substitution and integration by parts. Like if I say that I'm having an integrand, you know that the function expressed over here like this integrand is expressed here as the product of two functions. Excuse me. Okay, so if I just say that if one function, like if it is like this, okay, and if I say that if one function is said to be one function, this is another function, okay, so if I simply substitute x square to u, that commonly you just take it as u substitution, that's why I'm just substituting x square by means of my u. So on derivating both sides with respect to my x, the original variable, I just come to know that, the derivative of x squared is 2x, and is equals to du by dx, and this dx will go over there, so this dx. So you see this 2x dx can be replaced. It can be replaced as by means of du. Okay, so here you see, if in the integrand which is expressed as the product of two functions, if one function can be evaluated as the derivative of the other function, in that case you can freely use the process of your substitution, and that's how you perform your integration, like that, and then you restore and you just got your answer. Okay, but that's how you perform your substitution. So in general I can say that if your integrand is expressed as the product of two functions in which one function is the derivative of the other, then you can simply perform this integration by means of substitution. Okay, all right. And in case if you are having a case like this, like I say I am having an integrand which is the product of these two functions. Okay, so now you can see that none of the function can be expressed as the derivative of the other. So over here you're going to apply the concept of by parts, and by parts you have to focus that which function you should take the derivative of it, and which function you have to take out the integral. Okay, so over here you can focus, it's just a mere example, over here you can focus that the integral of ln x or log of x is not available. Okay, so you cannot take this function as the integral part of your integrand in case of performing by parts. So you should take it as a function in which you have to apply the derivative. You have to differentiate. So you have to take this function as a function whose derivative you have to take out. And this function, you can see that this is a function, exponential of x is a function whose integral as well as derivative both exist. So this one you should take as a function that whose integral you have to take out while performing the by parts. Okay, so a function in my while discussing a general formula, I should mention I just expressed the general formula of my by parts with respect to f and g. Mostly students also refer it with respect to u and v. So it is your choice how you're feeling yourself convenient. So I just take a function whose derivative I have to take out. I just take it as my f of x. Okay, and the function whose integral I have to take out while performing the by parts, I just take it g of x. Okay, so the formula of my by parts, the general formula of my by parts, whose integrand is expressed as the function, as the product of two different functions such that none of the function is the derivative of the other, you're going to perform a by parts. So you see it is equals to this. Sorry, my bad. It is g of x dx. Okay, so now the question might arise in your mind, what is this capital G of x and what is this f prime x? So I must say I have just told you that a function whose derivative you have to take out, you just take it f of x, and a function whose integral you have to take out while performing a by part, you just take it g of x. Okay, so once when you derivate the function f of x, this is the derivative of this function f is called f prime x. Okay, just one derivative of it. And when you take out the integral of this function g of x, it is expressed as capital G of x. This is the integral function plus some constant. So this is what you say, that this is the original function f of x. You take out the product of the integral function of this g of x minus integral of the derivative of this function f of x, the product of this function with the integral of this g of x function. So this is a general formula. You have to bring this formula in your mind, turn it indelible. Okay, don't forget that. This is it. Okay, so I must repeat that more you practice and more you perform the questions, a large set of questions related to substitution and related to integration by parts, then you are able to differentiate after looking at the integrand, that whether you have to solve it with respect to the substitution or do you have to apply the by parts in it. So more you practice, more you get perfect. That's the only way of turning yourself saturate and to strengthen your grip in different types of integration methodologies. Okay, so now let's move ahead to the examples. Okay, now here you go, the example. Over here you can see it's a simple ln of x. So though we can simply we are unable to perform simple integration on this integrand, because you know that the integral function of your ln x does not exist. Okay, the derivative of this function exists but not the integration. So you see, you are here to apply the integration by parts in order to evaluate this integrand. So now the question perhaps come in your mind that the integrand is not expressed here as a product of two functions. So just try to look at it more deeply. You can see that if we just simply put 1 over here, that 1 into ln x gives you ln x. So this function is the product of two functions, out of which one function is the unit function that you call it 1. Okay, so this is the formula for the integration by parts. And if you're not interested in expressing each function as a univariate function, you're not interested in mentioning the variable of that function through which it is expressed, you can simply write this function by means of this notation. Okay, so it is in calculus it is permissible. You can hail yourself with this facility. Okay, so now let's move ahead and try to figure out this integrand. So as I told you that in the previous while we were discussing the formula nature, I told you that I take that function whose derivative I have to take out while performing the by parts. I just take that function as my f of x, and the function whose integral I have to take out while performing a by parts, I just take it as my g of x. Okay, so over here, if I just try to further portray this integrand, I can write it like this. Okay, it is like this. So over here, this function whose derivative I have to take out is going to be my f of x, and this function whose integral I have to take out, I just take it as my g of x. Okay, so and remember that in some cases you just have an integrand out of as the product of two functions in such a way that the derivative and integral of both functions exist. In that case, it is your choice. You can take any function as your f of x and any function as the g of x of your integrand. Okay, over there you have your choice. But in case if you are having a function whose you are having an integrand as a product of two functions, out of which only one function derivative exists and the other ones does not exist, in that case you better take that function f of x whose derivative exists only. Okay, so just keep yourself focused on the nature of the integrand. Now let us make a column over here for my convenience. I just perform it by making column. It's your choice how you do it in your own way, but this is my way of doing work. So I just take it as my f of x as my ln x, and this is g of x, I just take it as my 1. Okay, now I'm going to derivate both sides of this equation by means of my variable x. So that's how I'm going to get my f dash x. So this is going to be my f dash x, and the derivative of my log of x is my 1 upon x. Okay, that's it. It is done. Now come over here and you're going to apply the integral at both sides with respect to x. So integral, this is it, and it's your choice. You can either write 1 or just leave this place empty, because it is understood that once there is nothing in the integrand, there is 1 over there. So it's your choice whether you write it or not. So the integral of 1 with respect to dx is x plus some constant. So now g of x is in front of you, f dash x is also in your service. Let's highlight these two functions. Okay, now we are going to apply these two functions in our formula over here. Okay, so let us do. Alright, so my integral of ln x is equal to my f of x is my ln x, my g of x is this. Okay, it's going to be x times ln x minus integral my f dash x is 1 upon x, my g of x, capital G of x, is my x. Okay, it's going to be 1 upon x dot x d of x. No need to write the constant over here. Okay, so this is going to be cancelled out, and just 1 is left over here in the integrand. You can write it either or not, it's your choice. So now x ln x minus integral of 1 with respect to dx is x, as I told you already, plus some constant. Okay, so over here in these two terms of the function, x is common, ln x minus 1 plus some constant, and this is it. That's your answer. Okay, so that's how you perform integration by parts. Let's move ahead to one more example. So here you go, one more delicious example over here. Now you can focus that the integrand is the product of two functions. Now let's see whether which one should be our f of x and which one should be our d of x. You can see that ln of x is over here, and its integral does not exist, only the derivative exists. So you're going to take this as your f of x, and the other one will obviously be your g of x. So just take it. F of x is your ln x. Just make a proper column, and your g of x is your x power m. Okay. Now over here you have to take out the derivative of this ln x, natural log of x. It's easy for me to say. Differentiate both sides with respect to your original variable x, and you are done. Then you're going to get your f prime x after that. Okay, so your f prime x is equal to your 1 upon x. That's it. It's done. Now let's highlight this. And move ahead over here. This is the function whose integral we have to find out with respect to our x. So it is going to be our g of x. And you know that integral of x power m is going to be x power m plus 1 upon m plus 1. It's something that we have already discussed in one of our previous lectures. Let's close this in the box. Okay. Now f of x, this is g of x. Let's write in short for your convenience. F of x, this is your g of x. F of x, g of x in front of you. F dash x and capital G of x is right in front of you. Substitute in this formula, and you are going to get your answer then. Okay. So this is ln of g of x, f of x, like that, and it is equal to your f of x is your ln of x, capital G is this thing. Okay, let's write it down. Ln x minus integral, our f dash x is 1 upon x, g of x is this. Let's write it at this place. Okay, you know that your m is taken as a number here. It is basically a constant thing. So 1 upon m plus 1 is a constant stuff. So you just take it outside your integral. And this x having power 1, when it goes upwards, this power is going to be written with the opposite sign, and that's how you do. Okay. So this one and this one will get cancelled because of the opposite signs, and you're going to have simply integral of x power m d of x. And now just simply apply the formula of xn over here. The integral of your x power n is nothing but this. Okay. Okay, so that's how we have just obtained. I'm sorry, there's a multiplication sign here. Okay, so now you see in these two terms you are having x power m plus 1 upon m plus 1 common, so you just take it outside. Let me do the work over here. So integral xm ln x d of x. You just take out your xm plus 1 upon m plus 1 common outside. So inside the bracket you are going to be having ln of x minus 1 upon m plus 1 constant minus constant upon m plus 1. But this is something that is so left, and you are done, and that's how you evaluate the integrand. You just evaluate the integrand by taking out its integration by means of parts, because you see that none of the function can be expressed as the derivative of the other, so you were unable to perform here the substitution, so you just took the help of the by parts. Okay, so that's all for this video. And just if you find this video helpful on the concept of by parts, is you feel that it is somewhat clear in your mind, just subscribe my video so that you are going to get you will keep on getting updated with my new launches. And in the next video, inshallah, we are going to have a look on some more examples related to integration by parts. So I hope that is going to further enrich this topic in your mind more deeply. Okay, so take good care of yourself and practice well, and try to pour yourself deeply in this subject and develop high. Allah Hafiz.